down from near you if there's chairs. They want to make sure that everybody who has a language partner is working next to your language partner. Si tú tienes un compañero de lenguaje que te ayuda, necesito que estés junto a ese compañero y que ese compañero esté, pero al tiro el día de hoy. Who's using a language partner or who is a language partner?
Oscar.
All right, good. Louder, my friend. This is a great talent. Anybody else?
He's sitting between right.
Okay, perfect. Entonces, ¿tú vas a ayudarlos a ellos dos? Okay, y yo hablo español, entonces cualquier cosa ustedes pueden decirme. My name is Mrs. Waltz, and I work in the district. I am a math coordinator, which basically means that I try to make sure that what we have to teach math is the best that it can be, and that everybody is using it the best. I work with middle schools and I work with high schools. So I know what you're gonna be learning next year. And so I'm working on learning more about Desmos because Desmos is new to us, right? So I'm learning how to work with Desmos. Ms. Woodring was very kind to let me come play with Desmos in her classroom today, and that's why I'm here, okay? So today we have a lesson on solar system, and you should have written that in your planner already with pink, because you know that, you do that every time, right? So you can give me a thumbs up if you already wrote that in your planner, and if not, go ahead and do that. And the planner, ¿ya escribieron la parte rosa? Okay, let's go. In a planner? Yeah, the pink part, right? You lost your planner? All right. We're gonna go through our content goal, our language goal, and our social goal. And you might have not done this before, or maybe you have done this in different classes. But what we're gonna do today is that I am going to read the black part, and you are going to read the red part, okay? We're gonna try to do it in unison, which means that you're all gonna sound like one sound. I'm gonna start with the content goal. Content goal, I can tell, we're gonna try that again. Content goal, I can tell
If a number
is written in
scientific notation.
and rewrite it if it isn't. Language goal, I can describe
A number within scientific notation.
by noticing patterns. I can use words such as,
Digits, factors, and powers of 10.
and our social goal is I can
Work with a partner.
and
Share my math thoughts.
with the class. So, our social goal is to work with a partner. Make eye contact with the partner that you have, and if you do not have a partner, make arrangements so that you do have a partner. You can move. If you're gonna be working together, one of you needs to move. And you have two partners right now, okay? And what about you in the back? Who's your partner? Find a partner and be in a partnership of 3 if you need to, but let's make adjustments to get going with that. Great. And so what we're going to do today is that we're going to be trying to make discoveries based on patterns. And for that, we are going to talk a little bit about why. So in Unit 7, you have been learning words like base and exponent and power and the rules of exponents. Now you know what to do when you have to add exponents and when exponents are like on top and the bottom of the fraction, right? And so today we will learn about scientific notation for very large and very small numbers. We're going to use it in 2 different ways so that you can do operations with exponents and learn about exponential functions and square roots in the future. Some of this is in the future of 8th grade, and some of this is in the future in high school. I was also talking to my daughter who said that she's using scientific notation all the time in physics, which is the 3rd science class you need to take when you get to high school. So this is important information that you will need to have. I'm gonna have you go into the platform right now, and I'm gonna have you work on the warm-up, which is slides 1, 2, and 3. We're going to take about 5 minutes, and you can consult with your partner if you need to. You're working on slides 1, 2, and 3 of the platform. You should already have them assigned and ready to go. Everybody should be in the warm-up. Slides 1, 2, and 3. 3 friends are already there. going to start my timer because it's really important to me that I work quickly through what needs to be worked through. Okay, so now you're working on this. Ordenabas de mañana. Okay. Consult with a partner. You don't have to figure this out all alone. And you're working through the first 3 slides. Make sure that you consult with a partner. This is part of our goal for today. Where can I see your dashboard so that it's not projected? Is it also on your computer or is it just on the board?
I can put it on my computer. It's just on the board. Usually I go
Okay.
back and forth.
Okay, okay. And that's fine. For now, I think that's fine.
I wish I had a setup.
Where he has both screens.
I've seen some teachers that will have
All right, I see that some friends are moving on to the second slide of the warm-up.
for the screens, the slides, but then they'll have their iPad for the actual noisy business. They'll do the computer. They'll do one for each basically, and then I can see everything that's going on still.
And it does give you feedback, so you know if you did it just right or not quite. So you can go back and fix it before you move on to that next slide.
Most kids do.
It's going positive. So which way is it gonna go? That's negative.
There you go. And when you're done with slide 2, go right ahead to slide 3. And slide 3 is going to have the list of both answers. And then you're going to have to explain what was easier to do and harder to do. I do appreciate that I hear one group of partners talking. I should be hearing a lot more people having these discussions. Good, 3 partnerships are discussing. You can move on to the next one and see if the next one makes it easier to order. If you're still working on the first slide, go ahead and move on to the second slide and see if that one is any easier for you. We have just about another minute to complete slide 3. I'm going to sink you to slide 3 so that you can all be working on that one. What list was easiest to sort and why? Yep. And when you explain your thinking, you can say it was easier because, and then explain what made it easier. If you are a money Daniel Vasquez, and you said it was easier because it was easier. That is not helping me one bit. You can explain a little bit more than that. Remember the words that we know: base, exponent, power, factor. Looks fairly even. Looks like 8 people, 9 people think it was the second list. How do I scroll down, Ms. Woodring?
The most.
The most, yes, the most.
Oh, I see it. I see the bar over here. All right, somebody's already saying they were written in scientific notation. I don't know if they all were. So the bigger numbers were easier to find out that they were bigger. And then somebody used the exponent to find out which one was greater. Mary says, list 2, the numbers are easier to sort. Somebody says it was in a linear pattern, which I wish we had more time to explore. Bigger numbers. Okay, so the exponents definitely help, right? We're gonna go into the next slide, and that one we're gonna spend a little bit of time on.
Is that a touch?
It's not a touch.
Nope.
Thank you. So I do this, and I'm gonna sync, and I'm gonna pause you for a second. Okay, so today, one of the big things that we are doing is that we're talking about what scientific notation is. It says scientific notation helps us compare numbers that are super large and super small, and some of the numbers in this table are written in scientific notation and some are not. There's a table. You're gonna see that yes, this is scientific notation, and you're gonna see the sign that says not scientific notation. Today, you get to decide what are the rules. What makes a number be scientific notation? So you're gonna look at the two sides, and then you're gonna say, what are the rules? What makes it be or not be scientific notation? So I am going to unpause you, and we're gonna spend a few minutes here, and then we'll talk about a definition of scientific notation based on what you discovered. Talk to your partner. What patterns do you see?
We do the scientific notation have.
¿Por qué los de la
And
izquierda sí
what
son
else?
los científicos
We've got
y los de la derecha
coefficients.
no?
Yep, that's with exponents, and what else do you
Or what do you
know about
know?
the 3 and this 1 and this 2 and 5?
Yeah, it's all by
I know those, that's
You know, is anything
Right
about
then,
these
and
numbers?
then talk about your 9.
Are there any numbers on this side that you know what I love? No. Are there any numbers on this side that are bigger than what? Like, how big are the numbers that start? Are they big numbers or small numbers? Not small, right? Small digits before the decimal point, right? And what about on this side? So that's a rule. Can you try to put it into words? To be in scientific notation, the number needs to be
What's that? First number, one whole number, and what? Period. And what is not scientific?
I put an abbreviated sentence frame for you. A number in, and I just wrote SN because it'll take forever to write scientific notation, needs to be, so find some patterns. What does it need to be?
8 or 10.
It needs to be more complicated. Okay, sure.
Yes.
Once you learn how to read it, it should not be so complicated.
1.
Okay, the colors are black. Are they all black? How are they different in one from the other? It's an equation. The more difficult written one. Okay, needs a number and a decimal. Okay, so a whole number and a decimal. That we're going somewhere here. Non-scientific notation, they don't have tens nor decimals. Okay, so scientific notation always has to have a decimal. Does the first one have a decimal? It says 3 times 10 something or other. So maybe the rule is not the decimal. Has to have exponents, maybe. Ooh, it's smaller. Daniel Vasquez, you're onto something. It has a smaller digit. Look at the digit in the ones place in the scientific notation column. How big is it? How big does it get? It has tens and decimal points and exponents. I think I'm gonna write them over here. We have 3 times 10 to the 9th power. I have a question for you. Are the numbers the same on the rows? Are the numbers here, is this the same number as this? Is this the same number as this? They are, aren't they? They're the same number, just one is scientific notation and one is not. Nope, not a touch. Ooh, everybody, all the numbers have a decimal point in the middle. More difficult written one needs to be more black and white. I wonder what that means. One whole number and a decimal. E3 coins. Needs a number and a decimal. Okay. Have most people's thoughts in there. All right, friends. I'm gonna sync you to me, and we're going to paste you right in there. Because I see that some of my friends are starting to move along. So, let's talk a little bit about a definition of scientific notation. Do all the numbers on this side have a factor of 10? Remember what a factor is? It's one of the parts in a multiplication equation. Do they all have a factor of 10?
No.
Yes. Do these all have a factor of 10? Do they all? Nope. Okay. Do they all have an exponent on the factor of 10? Okay. I want you to think about the size of the whole number on that side. What can we say about the size? It's a number that is between what and what? Are there any numbers that are less than 0? You can look on your own screen. Are there any numbers that are 2 digits, like in the tens, in the whole number part, that are like 11 or 12? Are any of these numbers bigger than 10 on the yes scientific notation? Are they? Well, just on the one factor. Are any of that one first factor bigger than 10? Which one is bigger than 10? Okay. So the definition of scientific notation is a number, and I'm not going to give you the official one, that has two factors. One is a number between 1 and less than 10. So it could be 9.99999, it's still less than 10. And a power of 10, and we're just going to leave it at that because the power of 10 is 10 with any exponent up here. Okay, so it's a factor that is less than 10, between 1 and 10, by a power of 10. Is how we're going to define scientific notation. So it's a 3, which is a number between 1 and 10, times 10 to the 9th. A 1 and 257 thousandths is still between 1 and 10 by a power of 10, and so forth. Does that make sense? You're going to be writing these numbers in scientific notation in the next slide. I'm going to model how to do that, and then I'll show you where you're going to go next. So I am going to pause you.
Not a touch.
Not that, sorry. Okay, it is kind of what it is. I'm going to open it up. Cancel. We're going to go all the way to 10. And before I unpause you, I'm going to show you what we need to do. And I want the student view. There we go. Okay, so we're going to be going through this one, and we're going to be trying to get Mercury's orbit going. If you do it right, it's going to show Mercury orbiting around the sun. How you're going to do that is that you're going to write this number in scientific notation. We are going to have to fill the rules. We're going to have to make it a number between 1 and 10 times a power of 10 to make it scientific notation. I'm going to model how to do that. I'm going to try it. I am going to need my keypad because I need numbers. So I am thinking that I need a number between 1 and 10, and the first digit over there is a 3. So I am going to write 3 6/10. And I know that that's going to be my first factor because it's my whole number that is less than 10, and everything else is 0, so I can do the zeros with a power of 10. I'm going to do times 10. And I think by this point you all know how to write an exponent using Desmos. But you're going to do the A with a B as an exponent. And what should my power be? You know what? I'm just going to try something. I am going to think, okay, there are 6 zeros over here, but then I have another 6 over there. I'm going to try a 6, a power of 6. Am I sure? No, I'm not sure, but I'm going to try it. Because part of what I'm doing today is I'm trying to find patterns. Nope, it's telling me that I'm wrong. So I have to think, why might I be wrong? I have 6 zeros. Oh, but I have a 6 over here on a decimal place, so it's probably a 7. So when it's your turn, I want you to try and get it wrong, and think why, and try it again. And use your partner to do that work. You're going to be working through several slides, and I want you to try it, find the pattern, and fix it. So I'm going to fix it. Try again. And I think all I need is to back it up 1, do a 7, and I got it right.
Oh, wow.
It's orbiting. So this is what you have to do. You're gonna try it, you're gonna try it again. I'm gonna go out of this one and show you what you're doing next. So on this slide, now that we've got Mercury done, you're gonna have to do the orbits of another 3 planets. Then, you're gonna go into this try it and see how we're gonna do scientific notation for really tiny numbers. This slide is super, super fast. I'm not even gonna try it. It's just gonna show you how it fills the tubes. This one will overflow, this one won't have enough, and this one will be filled all the way to the brim. That's what you want. And in your next one, you are going to again try it. Try to get all 3 tubes to fill all the way by writing scientific notation. When you're done with that one, you're gonna do a sort. And in this sort, you're going to have to say what is scientific notation and what is not using the rules we have learned today. If you get that far and you finish that, there's gonna be an are you ready for more? And if you're ready for more, that is great. We're all gonna meet at some point on slide 11. I'm gonna give you just a certain amount of time so you don't have forever, and we're gonna meet on slide 11. So at this point, you can get going starting with 5. And remember, the important thing is that you try it, find the pattern, try it again. Time flies when you're having fun. I want to see some planets orbiting, so raise your hand and invite me over when you do get that. You got it? Good. Now let's get the other ones to orbit. Alright, so remember how we did that one? Remember how you have to start with your number, so you have to start with your 3 and 6/10, because you need to have it be less than 10. So you have to do your 3.6. You're always going to start there. And now, times 10. Now you have to decide what exponent you're going to use. Okay, so you're always going to have your number. That is between 1 and 10, but it has to be less than 10. Times, which is going to be done with your little asterisk. 10, and you're going to have to decide your exponent, and that you're going to do with a key that has, I think, like an A to a B power or something like that. So you're always going to follow the formula. You have the number times 10, and then what exponent. And I'm looking for people who have gotten. All right, so let's work on the other one. So you're going to start with the number between 1 and 10. You have a 6 and a 7 right there.
That's Carlson about that.
All right, can't wait to try it. All right, so far so good. All right, we just have to work on the last one. Over there, we already have 2 planets orbiting. We're just working on the last one. Let's try this. So you did the second one. Okay, let's try the second, the next one. We know we have to use all the digits that are not 0 in our number, right? So you're going to start with the digit first. With a 9. And then you need a decimal point because it can only be between 1 and 10, right? So you know already 2 parts, 9 and a decimal point. Now we need all the other digits that are not 0 in there. Sorry. Yeah, yeah, 9, 6. Now we need to do the power times 10 and then an exponent. And the trick is, what exponent are we going to use? Go for it, try it. All right, you can try it already. Let's see how we do. Excellent over there. Excellent with Earth. You're doing great. Now you just need to do it for Mars. Right. Fantastic. I'm glad you're trying. Okay, so you got it. Okay. Looks like Mars is the final frontier, huh? Let's get Mars going, and then you can move on to the test tubes and see if you can make it work with smaller numbers. You can try along the way. Puedes intentarlo. You can try along the way. So here, we're gonna start with a 6. And then your decimal point, and then your 7.
It's orbiting.
And then you're doing it times 10. Dijo, la multiplicación es este. And then to your power, good. And then what is the number you're gonna use? Okay, you can try it and make sure that you're right. Are you trying it? Try it and make sure that you're right.
It's just gonna show you this one's overflowing. This
Great.
one's
Now keep going. Good. Looks like somebody's already on the test tubes. You can try and see if you're right. All right. Which one was not right? Mars? What? Okay, so try. Let's see what you got.
Either 1 point over or 1
You need a whole number first. That is between 1 and 9.99. So less than 6.
Jesse, what's Earth?
What's your first digit? Start with that. Decimal point. Then what? Yeah. Great. Times. 2, the power up?
Yeah.
Now, figure that out. You already have 5 over here. What else do you need?
Because you're using this.
How many more decimal points did you need?
9.29.
How many more decimal spaces do you have?
And then you have to go all the way
Okay,
back
so then
over.
it's 5 and then those
So
3.
this one
Let's
is-
try that. You already had a 5 and we moved 3 more spaces.
It's already in.
What did you try before? So you have a square root of 5. And now you need to multiply it by 3 more powers.
I'm just
So you need 5 and then 1 more and then 1 more and then 1 more. Try that. Yeah, thank you. All right, now go to your next one and work how to do it with little numbers. This is just gonna do a demo of what it means to fill the thing, okay? So you can pass that one pretty quick. All right, I see some friends that are working on the test tubes now. You got it, good job.
Times 10.
Okay, got it.
So it needs 3 more.
Ms. Rodriguez, this is not gonna work with the timing I got. And it's just not, it goes fast. But you know what? They're trying it and they're getting it right and they're doing the work, so this is a good math thing. I'd rather that
And
than.
in your head, you're like, oh, 45 minutes isn't
Yeah,
bad.
that's not bad.
That's what it's built for. But you forget about like the 3 minutes that it takes to actually get in here and get settled. And, yeah.
And they did great with that. They didn't give any time at all.
Yeah.
But it's just good to see that they're actually getting that into the math here. Okay, amigo. Try it. A ver. Okay, so here, 9.2 is how many, ¿cuál es la que se le hizo? So we're gonna do that, and then one will say, oh, it's.
I agree with the 1 and 2
Okay, super.
9, 6.
Okay, that's right. Espera un 6. Pusimos un 9.2. Oh, ¿sabes qué? Eso te falta las
How do we
cosas.
all over
Tiene que ser
How do we find that?
9.2 Vas a usar todos los dígitos hasta antes de llegar a los 6. Okay?
So between the decimal is correct.
Okay, did you try it already? We're working on it? All right, we have some friends that are already filling some test tubes, figuring out how to do scientific notation with teeny tiny numbers. Did you do it? Did you try it? Looks like this one needs a little work yet.
If I found it like
You can try it along the way and see if you're right or wrong. Alright.
This isn't like moving the decimal over.
I'm going to pause you and sync you to the card sort in 5, 4, 3, 2, 1. And you're paused. I apologize, but I have to sync you because otherwise we're not going to get to the very important part of today. Let's quick work on this one. Work on your card sort and tell me which numbers are in scientific notation and which ones are not. That's what you're on. We're going to give it just about a minute. We don't need way more time. Summary. Teacher, that's the one I want. Because then you can see if you got them right or not quite. You're still paused right now? Should be synced.
¿Tú crees que yo sí? Well, you're copying me, so I don't have to write. Esta vez es
Okay, now you're all there. All right, so do your sort. What is in scientific notation and what is not? You should not be lost. Doesn't say no, it says that it's spaced. Sorry, I'm gonna pause you quick because some of the right. I don't know why it's paused. Work with a partner, friend. All right.
Rather than have to open my other
Did we get them together? Good. Did you do it? Great. Did you do it? All right, so remember, we're looking for scientific notation, the ones that are following the rules. Meaning the first digit, the whole number, is between 1 and 9, or 1 and 10. No bigger than 10. So you're right, this is not. You're totally right. Is this scientific notation? Is this all 1 and 10? Then it's not. What about this one? Okay, so what about that one? Okay. Can you show me? Great, can you show me? Great.
Oh, did you see? Okay.
About to do this thing. All right, I just moved you, and we're gonna stay in the lesson synthesis, where we have someone who is writing scientific notation. They are trying to write it, and the question is this person using scientific notation, yes or no? And why yes or why not? We're going to go through these thoughts in a minute, and I'm probably going to pick some people to share. So be ready to share if this person correctly used scientific notation and how to write it correctly. And then we'll go into our synthesis, hopefully before the bell rings. When does the bell ring?
39. Is it 37 or 39?
37.
All right, we're going to do our best. We're
5
going to do our
minutes.
best.
I always forget.
All right, so one person says yes, a lot of people say no, but I want to know why. That's the most important part to me. Oh, the first digit isn't less than 10. The first digit isn't less than 10. It doesn't have a decimal point? Does it have a decimal point?
And then
It does. It's just right at.
No decimal point
what?
it says.
That's a dot. What is a period?
is not written correctly, right? Because it does not have a decimal point, it is a 10 as a whole number, and then it's too large. How would we rewrite it? Talk to somebody and tell them how to rewrite it so that it is in scientific notation.
I said no, because you didn't put the decimal in.
And then, did you write it correctly?
So what did you suggest? You said 1. All right, so I heard 1.0 times 10 to the power of 7. What other ideas do you have? Ms. Woodward, would you call somebody to share with us another idea?
Jazzy, you said that, didn't you? But what was your reasoning? Do you want the reasoning?
Yeah, I want to know how to rewrite it so that it's properly in scientific notation at this point.
So go ahead. She's afraid.
Oh no, don't be afraid.
Go ahead.
Decimal, when the zeros, moving the decimal to like the left, right.
I am so sorry.
I
I did not
know,
hear what you
okay.
said.
Well, read what you said.
That's not what's happening, that's not it. Because
Is it this one? Would you like me to read it for you? Okay.
we were not doing.
I just couldn't hear you. I wonder if anybody else did. So it's not less than 10. It doesn't have to have a decimal point. If it's a whole number, it doesn't have to have a decimal point. So the fact that it doesn't have a decimal point is not the mistake. The mistake is that it's a 10. So how you would change that is that instead of saying 10 times 10 to the 6th power, is that you would say 1, and you would multiply this by an additional power of 10, which would be 10 to the 7th power. I'm going to move you on to the cool down, because that's a really important thing that will help Ms. Woodring know if you, what do I do? Before the bell rings,
Wait.
go ahead and do your cool down.
Do the cool down
Before the bell
quick.
rings.
Do it.
Do it.
20
Do it.
seconds.
That's the most important part.
If you don't do it, it's homework. Edgar.